Hey guys, how's it going? Have you ever wondered why we need indexes? Whenever we ask this question, people tell us your database isn't capable of searching fast. That's why we need indexes, right? Indexes help your database search for a key faster, right? But why is that so? Why can't we just store data in a way that given a key, we find the value pretty quickly without having to store a separate data structure called an index, right? Why is that not possible? So in this video, we'll try to answer this exact question. So to answer it, let's take a very simple scenario or, let's try to focus on one small use case and let's see if we can kind of design a database where we don't need indexes and where inserts and searches are fast, okay? So I'm going to take one simple use case that given a key, find a value, right? We're not going to be doing given a list of keys, find values, or search for values inside our values and so on, right? For example, in SQL, if you have a primary key and 3-4 columns, you can also search by a column there, right? Let's not do all that. Let's say, okay, just given the ID, right, in MySQL or any SQL, let's say given the primary key, finding the row, or in a key value database, let's say given a key, find a value, right? Let's take a very simple use case like that, and let's see if we can kind of build a structure, build a database where we can create the database and have inserts and search to be optimal without having to create index. If we can, then we have our answer. And if we cannot, then we know why indexes are needed, right? So let's do that, okay? And remember, our only use case is given a key, finding a value, right? Nothing else, okay? So first approach, let's say we have a file, okay? And we store each key value in a single line, right? K1, let's say hyphen V1 or colon V1, K2, V2, K3, V3, K4, V4. Similarly, how many ever keys you have, let's say you store it in a single file, or let's say you have, let's say if you have a million keys, instead of storing in a single file, you store it in 1025, right? Essentially, a single file contains a set of key value pairs, okay? So if it's like that, okay, how will our inserts and search work? Insert is pretty simple. What we can do is we can always insert to the end of the file, okay, which is pretty fast in operating systems. You have a file open and this inserting to the end of the file is pretty fast. So inserts is fine. But when you have to search for it, you have no other way. Let's say you want to search for K4. You open the file and you go line by line and you see where K4 is. And you've got K4, then you see, okay, K4's value is V4. Or if it's not there, you return null, for example, right? So now this is order of n complexity. If you have multiple files, then you open the first file, you search line by line. Then you open the second file, then you search line by line. You open the third file, you again search line by line, right? So for search, the complexity is order of n. And now when you have a million keys, right, it's going to be very slow, okay? So this approach, although in search is pretty optimal, search is not optimal, okay? What else can we do? Let's consider a different approach, okay? In this approach, what we do is we have our disk and we say that for each key that we want to store, we're going to create a new file where the name is going to be that key and the value is going to be contained inside that file, okay? So for K1, you create a file called K1 and you store it. For K2, you create a file called K2 and you store it. For K3, you create a file called K3 and you store it. Similarly, for, how much ever keys you have. For Kn, essentially, you store a file called Kn, which has a value for the key Kn, okay? Now, insert is O of 1, right? Because creating a new file can be done. You don't have to go through each file to create a new file, right? Every key has its own file. So, insert is O of 1, right? Search is also O of 1, right? Because now if you want K5, you just need to go and open this file directly. You don't have to search for each and every file, right? So, search is also K of 1, right? So, isn't this a good approach? Here, our inserts are also O of 1, search is also O of 1, right? Why don't we do this, right? This is not optimal for a couple reasons. First reason is, although it looks like, let me zoom out a bit. Okay. Although it looks like, insert and search is O of 1, there is disk overhead here, okay? And the disk overhead is much more significant here, which actually makes things slower, okay? What happens is whenever you read a file from disk or any program reads a file from disk, there's something called a cache, okay, page cache. Essentially, files are cached in CPU so that the applications reading files frequently won't have to go to disk very frequently, right? If, for example, let's say K1 file is being read very frequently, so this is actually cached so that actual disk operation is not done. Okay. Let's assume, for example, our page cache has a maximum capacity to store 3 files. Okay. For example, right? So now what will happen when you read K1, you will have to go to disk, you have to do an IO. When you read now, next you read K2, you will again have to do an IO. Next you read K3, you will again have to do an IO. Now you read K4, K1 has to be, your cache has only 3 files of size maximum, right? So when you read K4, K1 has to be evicted, K4 goes into your cache and you do a file IO. K2, when you read now, it's going to come from cache because K2 was already read, so it's cached, right? Again, when you let's say next you read K5 has to go through IO. So you don't know in which order your reads are going to be received by the database, right? So when that's the scenario, the number of times you actually go to your disk and do a disk operation increases drastically because every file is just responsible for one key and value. So you do get advantages like that when you have a file with multiple key values, right? Which actually makes things faster compared to this particular scenario, right? Although from a time complexity perspective, it looks like O of 1 for inserts and search. It's actually slower because the number of times you have to do disk IO drastically increases, right? So frequent disk IO is expensive, right? That is why, so these are the two different approaches we saw, right? Either you have a single file because ultimately what databases do, they have to store the data in files, right? Because no matter what database they are, you only have the hard disk or SSD and they have to be stored in files, right? And we can think of two approaches. One is, let me go up. One is have a single file for multiple key values or have a single file for a single key value, right? There aren't any more approaches, right? So this approach, although it might seem like a solid approach, it'll work for small number of keys, but for a large number of keys, right? This is actually more expensive than storing something like this, right? So that is why we need an index. That is why we need a separate structure, written in this to make searches, inexpensive, right? So to conclude, we saw two approaches: store multiple keys in one file, store one key per file, right? In both these approaches, insert was O of 1, right? Inserts were pretty simple. Search in multiple key per file was O of n. Although in the next video, we'll see approaches where this complexity can be reduced, right? In one key per file, search is O of 1, but where the difference comes is in disk IO, right? When you store multiple keys in a file, your number of files reduces, right? So most of the files can be stored in page cache pretty easily. But when you have one key per file, right, your page cache cannot actually store millions of files. There's in every operating system, there's a number of open files that can be maintained, right? So your disk IO increases, which makes queries much more expensive, right? Although from a complexity standpoint, it looks like it's O of 1, it's slower in practice, right? So that is why we go with an approach of storing multiple keys in one file. Although the approach that I told you is not really efficient, right? O of n is still bad. In the upcoming videos, we'll look at different approaches on how to actually store data in the disk. How do these indexes store data in the disk to reduce this O of n complexity to something like O of log n complexity, right? Log n is of course much better than O of n, right? Much better, right? So yeah, in the upcoming videos, we'll take a look at different types of indexes. We'll see what are the pros and cons of storing data that way in the disk. And, we're going to be comparing all different approaches, to get really good idea and to get clarity on how databases work internally. I hope you guys enjoyed this video and I'll see you guys in the next one.